Okay, so if I were to ask you guys, unless your Algebra 2 teacher showed you this, you might not know how to do this problem here. What is 8 to the 1/3 power? We know what 8 to the first power is, 8 to the second power is. But what's 8 to a third of a power? What is it? How do you multiply 8 by itself a third of the time? That's kind of weird. So you would think, yeah, so it's going to make it lower, right? That makes sense. So here's the thing. We don't know what that is right now, right? But what I'm going to do is I'm going to do a little bit of math, and I'm going to use some facts about math that we do know to figure out what the answer is. So if this is where we left off yesterday, if I have x squared and I raise that to the 5th power, what's the answer? X10. So the rule is that when you have a term with an exponent on it and you raise that to an exponent, you multiply those, okay? So I'm going to use that little rule right there to do something. I don't like this 1/3 here. So what can I multiply that by to kill it?
1/3? Negative 1/3?
No.
3.
3.
How?
3 times 1/3 will kill it, right? Now, I want to multiply 3 times this, right? So that means I need to raise this side to the 3rd power, which I'm totally allowed to do if
You do it to the other side.
you do it to the other side. So now this cancels this, and I'm left with this. And so this thing is really just asking me what number to the 3rd power is 8. And what is that number? 2. Now, what's another way of writing this? Instead of saying what number to the 3rd power is 2, you got it. That's just the same thing as saying the cube root of 8, isn't it?
Sure.
So here's our big aha then. Ready? We don't need to have all this work. We've just basically shown that this is really a root. And so here's the rule. Whatever number is down here, that's the kind of root you're taking. Because that's what you'd have to multiply both sides by, right? All right. So there's that. Now, what if we were to complicate the matter a little bit? A little noisy. What if we were to change it a little bit and change it to the 2/3 power? Well, don't let that stress you out too much. What is this? X squared times x to the 3rd. What does that make? It's 5. The x to the 5th. You add the exponents, okay? So now, don't you guys agree then if x to the 2nd times x to the 3rd is x to the 5th? Couldn't I just say then that x to the 5th is these two things put together, right?
Yeah.
So in other words, instead of putting 8 to the 2/3, don't you guys agree I could just rewrite that as 8 to the 1/3 times 8 to the 1/3?
Yeah.
Because that's 2/3, isn't it?
Yeah.
If you add them. But we already figured this out, right?
Yeah.
So this is the same thing as saying 8 to the 1/3 squared. And we've already said that 8 to the 1/3 is the cube root of 8. Right? So more aha, ready? The bottom is your root. The top is just a normal exponent like usual. Okay? So there's our aha. I can leave it. You don't have to write this, but you can. I'll leave it. All right. So this slide I would like you guys to write. I'm going to add something though. I'm going to add something to this. That needs to go way down. They're headphones, not speakers. All right. So, anyway, this T, it could go out here or it can go inside. So, I think, now here's what makes this lesson confusing. Sometimes it's easier to have it on the outside. Sometimes it's easier to have it on the inside. And unless you're really good at mental math, you won't know which one is easier in advance. So what I'm going to do is I'm just going to teach it one way. I'm just going to do it with the T inside all day today. But I'll maybe if I feel like you guys are getting it okay, I'll show you some cases where it's kind of easier to think of the T as being out here first. But anyway, go ahead and copy down this slide.
North. What?
Okay.
North.
Anyway, so let's review before we go on to any exercises. Ready? So when you have a number raised to a power that's a fraction, the bottom number is your root. The top is your exponent. I'm going to go ahead and go with the one where the exponent's on the inside for now. Okay. So. Really? Okay. Yep. I picked those letters on purpose. It'd be a little easier to memorize. All right, go ahead and write down number 1, please. Yeah. Cece, pay attention to them.
I'm writing it down.
Just number 1. Number 1. 32 to the 1/5 power, right? Okay, so the first thing we want to do is we want to rewrite this. So we're going to change this into a radical. And the bottom number tells me what kind of a root we're looking for. The top number tells me what kind of a power we're using. And all this is being applied to the 32. Okay? Now, whenever you raise something to the first power, do you really need the exponent there? No, you do not. So let's just get rid of that. So really what this problem is asking for is just asking us to find the 5th root of 32. It's not 6. It's 2.
That's it.
If you want to see why it's 2, what you would do is you'd break down 32 into its prime factors. There would be 5 2's there. And for every group of 5, which we just so happen to have, they produce a baby 2, and then they leave. And now since I don't have anything left inside the radical, we're done. Okay? Let's do another one. Write down number 2, please. Write down number 2. You're welcome. All right, number 2. Number 2. We have 81 to the 5/4 power, right? So what kind of a root am I taking here? It's a 4th root of 81 to what power? 5. So this 5, you're getting warm, but just a second. So first of all, I've got how many 81s under this radical? There's 5 of them, right? Because it says the 5th power, doesn't it? So what this really means is I've got 5 of these guys in here.
Is this one of those ones where putting it on the outside would make it easier?
No. All right, now, do I have any groups of 4 that I could take out? Do you guys notice I'm not breaking it down? I'm not going to break those 81s down. You know why? Because I'd end up like a million 3s all over the place. I don't want to do that. But I already have 4, don't I? So don't break it down. If you've got a group, then just leave it. I've got a group of 4 81s. There we go. They have a baby 81, and then they leave. But here's the thing. I'm still not done with this problem. You guys know why?
Why?
Because now we do need to break this down because there might be 4 of something else left inside of this one. And you're right, it is 3. So I'm going to continue my work up top here. So just in case some people are wondering, though, because I know that some people already know the answer to that, but I'm still going to break it down. What does 81 break down into? 9 and 9. And each of those 9s are 3, 3. So look, it just so happens that the 81 on the inside has or is comprised of 4 3s. So do I have another group of 4?
Yeah.
So that gets to come out also as a 3, and those are gone. And so now I'm left with 3 times 81, which is,
243? Or 241?
I think you were right, 243.
Dang, I'm smart.
Yes.
Wait, I get 243. 81 times 3?
Yeah. Yeah. All right. Let's do one more,
Hold on.
and then when it gets practice.
And then like when we practice, like, I mean, like this is my last time because I'm just writing it down. Because they owed me my money. And like for like 2 months, I want my money back. Anytime we had money, I want my money.
What you did, you just jumped that person.
No, because
Just ask some of the freshmen. They're not afraid to do it.
You say, "Where's my money, son?"
somebody give me some baby
Okay.
Bailey understands the ghetto.
Oh, I just recorded all that. Okay. So I'm going to call on you guys to walk me through it this time. Let me get my little card. So the first thing I'm going to write, Talia, is this symbol. This symbol is called a radical. But what's going to go here?
3.
3. And then I'm going to ask Tristan. What goes right here, Tristan? I agree. And then I'm going to ask Kaylin.
Yes.
What goes here?
2.
That's correct. Okay. Now, no, he's not here. Sophia, what do I do now? Yeah. So we have a square there, right? It's 16 times 16. Now, do I have enough to take a 16 out? I don't. So this time I don't get to do that. So this time I actually do need to break down those 16. Okay? So here we go. I'm going to ask, well, does anybody know what 16 breaks down into?
4.
Okay. 4 times 4. And each of those 4s breaks down into 2 2s. So each of these 16s has 4 2s in them, right? So here's what we're looking at. We're looking at 8 2s in there, right?
Why do you not just multiply the 2 16 covers together?
Because you have to break it apart anyway, right? All right. So we're looking for groups of 3. There's 2 of them. So I could take out 2 2s, which gives me a 4 on the outside. And on the inside we have a 4. Now, that's it.
What are we going to use this with?
What do you mean?
How do you use these formulas?
Why would you want to do this?
Yeah, in the real life scenarios.
Probably science. Or
Okay, guys, 5, please. Shushel. All right, so why do we do this? So we talked earlier about why do we simplify, or maybe it was in my Algebra 2 class. And basically the point is when you're doing math, you want to separate the rational from the irrational. This is a rational number because it's just like you can write it as a fraction or a normal number. This is irrational. An irrational number is a number that just kind of keeps going. It has no pattern. So it's a way to simplify separating the rational from the irrational. But that's pretty much the gist of it. I mean, I don't know if that helps you answer it all, but it's simplifying. Now whenever you get ugly answers like this, it's not that helpful. But I mean, what if I gave you something like this? Let's say, by the way, I'm going to show you guys a shortcut now, but the problem is the shortcut only works sometimes if you can do mental math. Okay, so what kind of a root are we taking here? It's a third root. Does anybody know what the third root of 64 is? It's 4. So we're taking the third root of 64, which is 4, and then we're going to square it, which is what? So the answer is 16. Okay? You find the third root, and then you square it.
What's the third root? Oh, that's like a shortcut.
4.
How do you figure that out?
I memorized
Oh, is
it.
it 4 times 4 times 4?
Yeah. Yeah, and so I memorized it. I mean, because you can only do so many of these because they get huge. Like if I did another 4, it's all the way up to 256 now. So that we're not looking at numbers that are this big, they kind of keep them pretty small. So after you do a few, you kind of like, okay, I remember that answer, I remember that answer, and I remember that answer. But yeah, you can just do this mentally. Do the cube root, then square it. The problem is when you get to weird ones like this where you have an irrational piece left over, that mental math effort kind of goes out the window. because it doesn't have a perfect root anymore. All right, anyway, so you guys have the idea. I'm going to throw some at you here. You guys go ahead and do 1 through 2. 1 and 2, please. I will circle it so that you know to do only 1 and 2. Other questions? So we're going to backtrack now. Now we need to review something that people kind of struggle with before we go any further. All right. Everybody write down this rule about exponents. X to the negative n is equal to 1 over x to the positive n.
Yeah.
No, n.
Have you heard of
Not
depression?
Yeah, I'll write that down. So this is a rule about negative exponents. And this is a rule that just students cannot wrap their brains around this one, and they screw it up. And no matter how many times I say, I'm trying to be very inspiring here in case you can't tell. No matter how many times we go over it, they still screw it up. It's just that it's not a very intuitive rule. It's not like obvious. It misleads you. Okay. So here we go. Like I will give people this question for the negative 2. And I get all kinds of answers. I get things like -4, -8, -16. I get all kinds of goofy things. No, it's not 2. Let me show you guys the answer. I'm going to give you more to practice. So here's the rule. So x to the negative n is 1 over x to the n. So this is blank to the blank equals 1 over blank to the positive n. And so what's the answer? It's 1/16. Good. Okay? Now the problem is remembering that. Because people do it and then they whoop, and then I start getting funky things like -16s and answer. So all right, so no. Okay, so how about this one? How about 3 to the -3?
I'll do it right now, sir.
Go for it.
Okay.
Too lazy, so I'll just say here.
No Isabella today.
Stop playing.
It's not 27. What are you thinking, Aya?
Yeah,
Patterson, what do you think?
1/3.
Yes. Okay, so this is 1 over 3 to the positive third power,
Okay.
which is 1 over 27.
Oh, yeah, that's what I did. You said no, so I'll do that.
Yes, well, the answer's not 27, right? It's 1.
Yeah, I'm just saying like.
You just said it wrong. All right.
Hey, man.
What? That's terrible.
I love that.
Okay, so now that we know that, let's go back and do a couple more problems here. Write down number 4.
Number 4?
Yeah,
Letter 4.
I say number 5.
number 4. Numero quattro.
Quattro numero.
Here we go. So we've got 25 to the -3 halves power. Okay. What I'm going to do is I'm going to find out what 25 to the 3 halves is first. Because it's going to be the same thing as this, just the reciprocal, right? Or I guess we could just say, let's be legal here. Let's write it nice. So don't you guys agree that that's the same thing as this then, right? 25 to the positive 3 halves?
Yeah.
Okay. So now we get to do our math. So what is what am I going to write on the bottom now? Square root, normal square root because it's a 2, right? Of 25 to the 3rd power. Okay?
But where's the square from? On the outside, right?
Well, the thing is, when it's a square root, we don't put it there, but yes, you can put it there. You wouldn't be wrong, but just don't be surprised if you don't see a number. That means it's a 2. All right, so let's keep up the work here. So I left off here. We have 25 cubed. Now, doesn't that mean I have 3 of those? Can I take anything out?
Is anyone 25? 1 over 1.
You're right. So I could take out a 25, right? But I still have a 25 inside. But I'm not necessarily done, right? Yeah? Sure.
So is this literally just the same process, just in practice one?
You could.
Okay.
Break apart. Now, what's the square root of 25, you guys?
You're welcome.
There you go.
So it's literally the same process, just in practice.
Yeah, so basically what you can do is you can just ignore the negative in the beginning if you want to. Solve the problem like you usually would, and at the end just put it under 1. That'll be fine. Because you get the same answer.
That's the end of today's lesson.
Not quite. We got a couple more.
Dang!
Ruined
it.
Huh?
It was totally not going to be it. You're a fault for coming.
Let's do number 5. Write down number 5. Let's write down number 5.
What's number 5?
Well, guys, it's right here. What's the problem here? This is like happened multiple times. It's like it's right there. I don't understand. What do you mean? Where's number 5?
Where is it? I don't see it.
Nah,
Really, I don't see it.
You would look at it and be like, oh no.
Really, I can't see number 5.
Whatever. All right. So I'm gonna use my cards. Dylan Smith.
Oh, yeah.
Because my exponent is negative, what am I gonna write?
You got to write 1, 2, 8. Where's the negative?
-8.
Negative 8. And then 1/3.
So notice that it changes the sign of the exponent, not the base number.
I got the answer.
Oh, you already have it? What is it?
1 over 2.
No I. It's because it's an odd root, and we'll get there. And that's why I included this, to refresh you guys a little bit on that. All right. So now what do I do? What does that 1/3 give me, you guys? Oops.
What is that? A smiley face.
Oh, I see what you did. It's a
Third root of negative 8. We really don't.
Sorry, none of us are that happy.
We don't really need the 1. Okay, but when you have an odd root and a negative, do you take out an I or a negative?
No.
You take out a negative, right? So I'm going to cross that off and put that out here. And so now I've got this. But what's the cube root of 8? We've done that a million times. So it's 2. So the answer is negative 1/2.
Bailey, how much
I
you trying to
remember
trick
it.
us with that
It's a downward arrow. What's confusing about that?
It's like
It's like two.
Yeah,
It's like a smiley face with like a creepy
smiley
look.
face.
Yeah, there you go.
You guys are having some visuosensory problems today. Visuosensory problem. I don't know how to say it. I can't speak. I'm having linguistic problems. You're having
It's okay. We know
visual
you're illiterate. It's okay.
Yeah.
Why did you just move the negative? Why did you put I?
Say that again.
Why did you just put I?
Because it's an odd root. And odd roots give us negative real numbers. All right, one more problem. Hold up.
I only remembered that because that's how I saw when I do squares or like cubes. That's how I remember if it stays negative. How do you
Write down number 6. Write down number 6. So I want to comment one more time on number 5. I think something you guys really want to watch out for is when I move this thing down to the bottom of the fraction bar, put it under 1, it didn't change the sign of the 8, right? It changed the sign of the power. Don't mix that up. It doesn't change the sign of the base. It only changes the sign of the exponent. Anyway, back to number 6. Here we go. So for number 6, we have x to the 3rd equals a half. Now or not equals a half, raised to the half. Now we talked about this earlier today. When you have a power raised to a power, what do? The first one you said was right. You multiply. So this is going to be x to the what?
3 over 2.
3 over 2, which is in radical form the square root of
X cubed.
X cubed. And x cubed is,
3x.
which means I can take out,
X square root. Okay.
that's it. Okay?
Hold on. There's not even any numbers.
There's numbers right there.
Talking about real numbers.
They are real numbers. There's no imaginary numbers up there.
That's funny.
Okay, here you go, guys, for you.
No.
I want you guys to do 3 through 5.
Good job, Ricardo. You probably would have only gave us 3, maybe.
So I'm going to go over all 3 of these, and if you didn't get one right, you can see why. I think number 4 in particular is tricky because we're wondering why the negative's not there. So let's go ahead and do that. So for number 1, we have 36 to the negative half. Step 1, reciprocal with a positive power. That's the negative exponent rule. Step 2, change it to radical form. Step 3, we can honestly just do that square root mentally and get 1/6. Okay? Let's take a look at the next one. The next one was negative 64 to the what?
Negative 2/3.
Negative 2/3?
Yeah.
Okay, so first of all, step 1 is to make a reciprocal with a positive exponent. That's the negative reciprocal rule. Step 2 is to change it into radical form. It's a cube root of a negative 64 squared. Now here's where a lot of people probably went wrong. You probably took the negative out because you were thinking, okay, Bailey said odd root, negative, just pull that negative out, right? Doesn't work here. Let me tell you why. Because that's not just a negative 64. What is that? It's a negative 64 squared, right?
No.
And when you have 2 negatives, what happens?
Negative 2.
They cancel each other out. So you got a negative 64 times a negative 64. The negatives they're not there. So that's where you probably lost it. Now at this point, we do have to break this down. We don't have enough to take any 64s out. So if I break down 64, you should end up with 6 2s. One, two, three, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I could take out 1, 2, 3, 4 2s for a total of 1/16. Now I also want to show you guys how I would do this one mentally. I'm giving you guys one set way of doing this just to make it not confusing. But really, this is actually quite simple if you kind of have memorized things. We've already talked about this is a third root of 64. What's the third root of negative 64? Negative 4. And then we square it. What do you get if you square a negative 4? 16. And since it's a negative, 1/16. So you guys see how you just do all that mental math? This is like cube it, negative 4. Square it, 16. Negative, flip it. You're done. So you could do that all mentally if you want. But working it out works as well. Last one. Negative 8x to the 5th to what power? 1/3. Okay. So no negative exponent this time. So we're not going to do the reciprocal, are we? Okay. So we're not going to do the reciprocal thing. We are going to change it into radical form, though, with my cube root out here. And in this case, the 8 is just an 8. So I will take the negative out. And then we're also going to break down the 8 into 3 2s and this x to the 5th into 5 x's. And we can take out a 2 and an x. But we're left on the inside with 2 x's, which is x squared. Don't forget your little cube and the negative in the front. So that's that.